Let's solve a vector problem involving an airplane's motion. An airplane is traveling at 835 kilometers per hour in a direction 41.5 degrees west of north. Let's find the components of the velocity vector and determine how far the plane travels after 2.5 hours. Let's start by drawing a diagram to help us visualize this problem. First, let's draw our compass directions. Now, we can show the airplane's velocity vector, which is 835 kilometers per hour at an angle of 41.5 degrees west of north. To find the components of this velocity, we need to break it down into its northerly and westerly components. We can do this using trigonometry. The northerly component will be adjacent to our angle, so we'll use cosine. The westerly component will be opposite to our angle, so we'll use sine. Let's calculate the northerly component first. Using the cosine theta, we multiply 835 by cosine of 41.5 degrees. This gives us approximately 625 kilometers per hour northward. For the westerly component, we multiply 835 by sine of 41.5 degrees. This gives us approximately 553 kilometers per hour westward. Now for part B, we need to find how far the plane has traveled after 2.5 hours. We can use the formula distance equals velocity times time. For the northward distance, we multiply 625 kilometers per hour by 2.5 hours, giving us 1,562.5 kilometers north. For the westward distance, we multiply 553 kilometers per hour by 2.5 hours, giving us 1,382.5 kilometers west. Let's visualize the final position of the plane. After 2.5 hours, the plane has traveled 1,562.5 kilometers north and 1,382.5 kilometers west from its starting position. This problem shows us how we can use trigonometry to break down a vector into its components, and then use those components to determine the final position of an object.